All right, guys, it's me, Mr. Moore again. I am today going to be talking about number systems. Now, number systems are typically started at the beginning of the year. This video is going to be a combination of 7th and 8th grade curriculum. That would be for my 6th grade pre-AP and my 7th grade pre-AP students. I'm going to do this video together as an all-purpose video. Towards the end, I'm going to decipher between 7th grade curriculum, which again is for 6th grade pre-AP, and the 8th grade curriculum, which would be for the 7th grade pre-AP. So first things first, we're going to do a 6th grade vocabulary review, which would be most appropriate for my 6th grade pre-AP students, and just as a refresher course for my 7th pre-AP students. So as you see there on the screen, your whole numbers would be any of the natural numbers, including 0. So that would be 0, 1, 2, 3. And there, of course, is no fractional or decimal part, and there are no negatives with whole numbers, okay? So the example that I have here would be for 5, 49, and 980 are all whole numbers, okay? So think counting numbers, but also including the number 0. So your rational numbers, those are going to be any number that can be made by dividing two integers. An integer is a number with no fractional part. So the example that we have here is going to be 1 over 2 is a rational number because 1 divided by 2, or the ratio of 1 to 2. And 0.75 is a rational number, also could be written as a fraction, 3 over 4. Now, let's think about this. Any number can be made into a rational number. So say the number 1. As long as I put 1 over the number 1, 1 over 1, that is a rational number. What about the number 6? 6 over 1, still a rational number, but can be phrased as a fraction. Then we move on to integers. Any of the counting numbers, including 0, of course, 0, 1, 2, or 3. But wait a second, that sort of looks like whole numbers if you ask yourself, right? But the only difference is there is no fractional or decimal part. However, this set of numbers includes negatives. So, for instance, I could have 5 is an integer. Negative 5 is its opposite and also an integer. What about 49? Yes. 0? Yes. And number 198? They are all integers. And then, if we look at 7th grade vocabulary, we think about the counting or the natural number. So what I have written here is that the whole numbers from 1 upwards count. So 1, 2, 3, and so on. So I want you to think about, when you think about counting or natural numbers, when your child was a kindergartner, they did not start with the concept of 0. At that point in their development, 0, it doesn't necessarily mean anything. They don't get that until later on in elementary, basically. So think of when they first learn to count, when they're counting on their fingers, the counting numbers or natural numbers, you naturally start with 1. You have 1 finger, then 2 fingers, then 3, then 4, then 5 fingers. And remember, there are no negative numbers and no fractions when it comes to the counting numbers also. Now, if you were in my 6th grade pre-AP class, this is where you would stop. Okay, you're going to stop the video because this is all that we would be talking about. If you proceed, this is where we go strictly into the domain of my 7th grade pre-AP students learning 8th grade curriculum. So we are back, okay? Now, as an intro to my 8th grade vocabulary for the 7th grade pre-AP students, we're going to look at real numbers. Now, you might ask yourself, aren't all numbers real? Of course they are, okay? But real numbers would be a more specific math term where the type of number that we normally use, such as 1, 15.82, negative 0.01, 3 out of 4, etc. They can be both negative, positive, large, small. Whole numbers or decimal numbers are all real numbers, okay? Now, the distinguishing factor is that real numbers, whereas in your 6th grade or 7th grade curriculum, you talk about rational numbers. You also include, when you think about 8th grade vocabulary and real numbers, irrational numbers. Now, an irrational number is a number that cannot be made by dividing two integers, okay? An integer has no fractional part, okay? An integer that has no fractional part, I should say. Now, your irrational numbers, if you look here at the example, okay, if you look at this example, and I'm going to move the screen over just a little bit. On the left here, where you see 1.5 is equal to 3 over 2, that is a rational number because it can be phrased as a fraction. However, the number pi, which is the example that I gave here, that is a number that does not end. It is a decimal number that basically goes on and on forever and ever, and it cannot be phrased as a fraction where I would put one integer over the other. Now, again, irrational means no ratio, so it isn't a rational number. A decimal which goes on forever without repeating, again, is an irrational number. Now, I do want to give one caveat. Now, the only integer that cannot have or make a rational number would be where the number 0 is in the denominator. Any number over 0 was going to be undefined and therefore not a number, okay, not something that exists, undefined. All right, so that was a very quick explanation of the number systems, both for my 7th and 8th grades. Remember, this last part was strictly for the 8th grade curriculum. See you guys next time.